Okay, today is Saturday, October 28th, 2017. Biostats Group 9, Lesson 14, Group Meeting Quiz. Wait, is it
Somebody in the quiz?
okay? I'm gonna start with question 3.
Perfect.
Yep.
In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. True or false?
True.
True.
Okay. Question 4. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply.
Normally distributed equal variances, right?
And variances are equal in each group, correct?
Yep.
Yes.
Agree? Okay.
Agreed.
Question 5. To check if each group is normally distributed, do the following.
I think you have to do a QQ plot.
Yep.
Agree. Okay. Question 6. We assume the variance in each group is the same if the following happens.
I think it's the second one.
Agreed.
Agree, that's correct. Okay. Oh, Elizabeth, I was going to ask you, so all things considered at your place and whatever with things, do you want to skip reading? Is that easier for you to skip tonight especially?
Well, I can read. I just don't know if you can hear me. Can you hear me?
Yeah, I can hear you. I just didn't want to.
Okay.
I just didn't want to.
Okay, well, I'll read
that
it.
if that was an issue.
It's okay. I'll read it. An ANOVA hypothesis test is equivalent to conducting 2 independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs: 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples?
So, why is that a hard question?
2, 3, 4, 2, 1, 2, 2, 2, 3, 2, 4.
I got 6.
1, 2, 3, 4, 5, 6, 7.
That wrong?
Could it be 7? I've got 1 could pair up with 2, 1 could pair up with 3, 1 could pair up with 4. 2 could pair up with 3, or 2 could pair up with 4. 3 could pair up with 4. Oh, I put 1 4 twice. My bad. I think 6 is a great answer.
Okay.
I agree.
All right, minimum variance. And for this data set, I already loaded it since I was slow man on the totem pole last time. But I didn't load the second data set, just this one. So the smallest variance
I got 27.208.
Yeah, that's what I got too.
I am still sorry. I haven't copied it.
You take your time, Kelsey. I just didn't want to. I just felt really bad about last time. I felt like I made the test take twice as long. What is the smallest minimum value for the 6 groups? 27.208.
Sorry, guys. One more. Date. So was 27.
Yeah.
Sorry, I couldn't hear you. What did you say?
27.208.
Yeah, that's what I got.
Yep.
Cool.
So that's the smallest. So what is the maximum or largest variance for the sixth group? Round to 3.
Right?
Right. So it's 53.158.
I got 40.724.
What did you get for variable 4?
Oh, 53.158.
I'm like, okay, Elizabeth, I don't know how to respond.
I'm sorry, please. Oh, let's see. Here's my quiz.
So the test for equal variances is satisfied for these data. True?
Yes, true.
Question 11. Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots.
Well, since it's a group test, maybe we could each do a couple of them.
I have honestly, how do you do the QQ plots? Is there a spreadsheet?
Yeah, you're going to have to copy a data set and stick it in the spreadsheet. I think you have to put it in the other spreadsheet, right? The quantitative descriptive statistics, the one that had histograms on it, it has a QQ plot thing on it.
Okay.
I just did the first 4 and they're normal, ladies.
I'm thinking
You
that
just did the first 4? How are you doing that so fast? I need to come see you. I am so slow. All right, well let me do number 6 then. I'll do the 6th one. Copy.
I need a bigger computer screen for all the screens that we have up during.
Maybe it's Peggy's computer. Yeah. All right, let's see. Started A2, and there was 19 of them, so I'll go down to 21. 3. We want a QQ plot. 21. Oh. Number 6 looks terrible unless I did something wrong. Peggy, since you're so fast, can you do number 6 and look at it?
Just one sec.
Number 5 looks bad too.
Number 6.
Oh, paste column A. Oh, I wonder if you have to sort it.
Oh, sort it. Oh,
Have you
my
sorted
bad.
it?
No, I didn't sort it. Hang on.
Wait, do you sort from lowest to highest?
It says lowest to highest.
From A to Z, right?
Oh, look, now it looks better.
Okay. It's about better now. I was like, what the heck?
I like it. It looks good.
Okay, there we go. So we're good on that one. True.
We're good on that one. True. What do I know? It says observe that the p-value is 0.081. Then remove the stocks data. Okay.
what is the p-value when we remove the SOX data?
SOX was 6, right?
Yeah.
Yeah.
See, since Kelsey taught me how to clear contents last time, I know how to do that.
Yeah.
0.309.
Yep.
Whoops. What is the p-value when we remove the SOX data? 0.309. Okay. The test statistic for an ANOVA hypothesis test is an F. Is the p-value to the right or left? I think it's to the right.
You're right. Yeah.
Agree.
Okay, I haven't done anything with this stuff. Hot dogs. Construct
I don't know, but it's making me hungry.
I know it's dinner time.
And
For,
compare the variances to determine the assumptions that have been met. Okay, 3 types of hot dogs. So shall we each try a QQ plot again?
yeah, that'd be a good idea.
All right, I'll try whatever's last. I'll do the last one.
I'll do the whatever second. So
So what am
All
I?
right, so I'm doing poultry. You're doing the first one, Peggy, because you're the fastest.
are we?
Oh,
are
wait,
we,
there's two.
are we
Wait,
supposed to
there's
look
two
at
different.
calories or sodium?
Yeah, I don't know. Hang on. I gotta go back to my quiz. Calories. It says do calories first.
Okay. Oh man, they're gonna make us copy and paste stuff twice.
Probably.
God.
The fun never stops.
Calories. All right, so calories for poultry. Control copy. All right, and then I'm going to put that in. Quantitative. Sort data.
What is normal?
Mine looks kind of okay. It's not terrible.
Hold on, I'm still sorting. Mine looks pretty good.
And we can also assume the variances are equal. Assumptions have not been met. Assumptions not been met. Not safe to assume each group. We also have to check the variances, it looks like. Hey Peggy, since you're so fast, can you look at mine and make sure you like it? It curves a little bit, and I'm just not sure how much of a curve is bad.
I know, I'm not either.
Mine curves a little bit too. Maybe we should. What's the variance? That's probably concrete.
Yeah, I was gonna go look at the variances because our answer choices are just so detailed.
Yeah, the variances are good.
Okay, so do we want to say the assumptions are met?
I think so. I honestly, I don't know. I think it's really fine.
Run the test to determine if the mean calories is the same.
All the options say that they have not been met.
No, the first one says they have it, doesn't it?
Yeah, but I don't know if that's right. I think it might be the second one, but I could be wrong. Unless you want to submit first, Elizabeth.
Well, I don't mind submitting first, but yeah, I'll submit first when we're done. I just, I haven't even put it in the one. I haven't even put it in ANOVA yet.
I don't think it's the second one because I think their variances are equal. And that one is saying that their QQ plots, that they're normally distributed. I think the QQ plots are what's questionable.
Yeah, I
Well,
just don't
the
know.
QQ plots don't tell us anything about
Well, they establish normality.
variances, right?
They're
Right.
what we're looking at to see if it's normally distributed.
I think I remember seeing that ANOVA is fairly robust, and even if your QQ plots are a little squiggly, it'll still be okay. Copy.
They are a little squiggly, but I think you're right, Elizabeth.
Okay, in case anyone's wondering what I'm doing, I'm still putting data in the ANOVA spreadsheet. Sorry. Please stand by. Oh wait, that's socks. We're done with socks. Hot dogs. Control copy. Whoops. Contents. Data. Beef, there was 19 beefs. Were there more beefs than there were the other two sections? 22.
Is beef the
Oh,
first?
yeah. Yeah, beef's the first one. I think there's more of those, isn't there?
Yeah, there is. There is.
Oh, okay. Okay, good. Because
I know. I always wonder. I'm like, did I do something wrong? When they're
that's
not.
what I was wondering. Okay, all right, ladies. I am now back with the program. Boy, these are huge variances. All right. What's the next question asking?
So, did you decide that it was normal or not?
Hey, look at question 17. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the median sodium levels are the same for all three groups. I think that's a hint.
I think so too. I think that means that I would go with the third one on 14. That the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population.
Let's examine calories first. Oh wait, did we just switch to sodium?
Not yet.
You should define the degrees of freedom are 2 and 51. Wait, did we miss 15? Did we do 15? Run an ANOVA test to determine if the mean number of calories is the same for all three types. You should find the degrees of freedom are 2 and 51, and that F is 16 and P is 0 with a significance level of 0.05. What conclusion can you draw?
What did we decide for 14?
Okay, you know what? Okay, look.
That's the one I thought we weren't sure of.
Question 16 says that if we run it for sodium on poultry, we'll see a problem. So let's run it for sodium on poultry so we can see what a problem looks like.
Oh, okay.
So hang on just a second. Let's see. Sodium for poultry. Quantitative. Put these in. Sort the dumb things.
That looks like kind of similar to what I think we were seeing for the calories as well.
I agree. The one I ran for calories didn't look any better than the one I'm looking at for sodium for poultry.
Right.
Okay, so yeah, Kelsey, I think I'm gonna. Well, I'm gonna submit first anyway, so just don't get too far ahead of me. This, so I'm gonna assume. I'm gonna say it's not safe to assume each comes from a normally distributed population, but we can assume variances are equal.
I agree with that one.
Okay, all right, that's the one I'm gonna. That's what I'm gonna try.
That was
14. And then 15, run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. If your p-value is 0.
I'm confused, you guys. On 14, are you looking at the calories data or are you looking at the sodium?
So here's what happened, Peggy. We were looking at calories, and Kelsey and I were uncomfortable being able to say whether or not ours looked normal because there were little curves in it.
Yeah.
Then we noticed just scanning ahead that 16 said there's definitely a problem for poultry sodium. So I put poultry sodium in there so I could see a picture of something that the test says is definitely bad. And
Right.
poultry sodium looked similar to my poultry calories. And so as far as the picture. And so I think if they're calling that picture bad for sodium, that maybe I should have called that picture bad for calories. Is that right, Kelsey? Do you want to add anything to that conversation?
I think that made sense.
Okay.
We have sufficient evidence to claim that all 3 hot dogs have the same number. We do not have sufficient evidence to reject the claim. We have sufficient evidence to claim that at least one. Okay, so I'm for whatever number we're on now. What number is this?
15, right? No, yeah, 15.
I think it's the last one. Because you have a p-value of 0.
Yeah,
I agree.
I agree.
Oh, this is a long test. Okay, now let's examine sodium levels. Yay! Construct QQ plots. You should see that poultry is bad. The smallest variance is that, and the largest is that. Have the assumptions been met? Okay, so the largest is 7, the smallest is 7, and the largest is 10. So the variances are still fine, right?
Yeah, but
while it is safe to assume that comes from it's safe to assume. So we want that same choice that we made for 14. We want choice C.
I think so. Assumptions have not been met.
Despite the possible problem with the QQ plot, you decide to use ANOVA. What is the p-value?
Oh man, I was hoping I could get away without entering it in there. I was like, oh look, they're giving us the info, but no.
Me too. Peggy, if you get it done first, just shout it out to us. Let's see.
Hot dogs.
Okay. And the sodium numbers are big. Okay. And beef. Control copy.
It wanted us to give the P.
I'm really close, ladies. I feel like I'm keeping up with the group. Done. Okay, what does it want to know? P-value?
Yeah.
I got 0.1793.
Yep.
1793.
Except only do 0.1.
So 0.179.
0.179. Gotcha. What conclusion can you draw about the sodium levels? We have
So
we do not have sufficient evidence to reject the claim that all 3 tacos have the same type.
Same mean sodium level, so B.
yeah. I agree with that. Ooh, we're at 18.
Yeah. All right, let me submit and see what happened. Yes.
You're so nice.
You don't have to be the sacrificial lamb on that, Elizabeth.
No, it's totally fine. Okay, let's see what I got. Oh, let's see, submit quiz. You get to put the button 3 times. Yes, submit the quiz. All right, we've got 2, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0. We missed 14.
Okay.
Okay, so somebody else try that everything's fine. Somebody try everything's fine on 14.
I will do that.
Okay, tell me how it goes.
Which one did you do on that? End up doing on that
I
one,
did-
Elizabeth?
I did C. Kelsey's gonna do A.
All right. Submitting. Pressing submit again, and yes for the last time.
I think it's B.
I think it's A.
It's A. I got 100.
Awesome.
All right, yay! Okay, ladies, so we'll meet again on Monday. And
So
Peggy,
Monday night,
you're checking
Monday
with us,
night,
right?
7 p.m. Pacific.
Yeah.
Yep, that works.
All right, ladies.
All right, good
Have a
night.
big rest of the night and a nice Sabbath tomorrow.
Yeah, keep me in your prayers. I'll be driving super late tonight.
Okay.
We will. You take
All
care
right,
and
good
be
night.
safe.
Okay, bye.
Bye.